Now we're going to look at the power rule. So when you have a power raised to a secondary power, you're actually going to multiply those together. Also, inside the parentheses that's being raised to a power, if there's something being multiplied together, though both of those items will receive that power. Same thing if you have a quotient going on, everything inside the parentheses will get the power. I just want to make a note. We're going to see this later on. If I had something, for example, like x plus 3 raised to a power of 2, that is not equal to x squared plus 3 squared. So that distributing the power rule only applies when there's multiplication or division. So not addition or subtraction. There's going to be a different approach to that, and that'll be covered in a later unit. So looking at this first one right here, if you follow the power rule, you're just going to multiply the 3 and the 2 together, and you get x to the power of 6. Now, if you remember, the power tells you how many times to multiply that base together. So another way of looking at this square is telling you to do x to the power of 3 times x to the power of 3. And if you remember from the product rule, you add the powers in that case. So you would have 3 plus 3, and you would still get x to the power of 6. We could even break this down more by expanding both of these, and you would see that there would be a total of 6 of them if we expand the x to the power of 3 on each of those. And once again, when we clean that up, you get that x to the power of 6. But obviously, the way we want to approach this is by the power rule. It's going to make life a lot easier for us. So looking at B, we can see that we have multiplication taking place inside the parentheses with the power of 4 out here. So that power is going to get applied to both of these. So we're going to get 3 to the power of 4 and also x squared raised to a power of 4. So 3 to the power of 4, when we expand that, that's 3 multiplied to itself 4 times. And then here you can just go ahead and do the power rule, multiply that and get x to the power of 8. All right, so 3 times 3 is 9, 3 times 3 is 9, and then when you multiply the 9s together, you'll get 81, and then we have our x to the power of 8 right there. Okay, C is not much different. We do have a negative base in here, negative 2, and we have x to the power of 7. So we're going to distribute that power to both of these. So we're going to have negative 2 to the power of 3 times x to the power of 7, also raised to a power of 3. So the negative 2 to the power of 3, we're going to multiply that negative 2 3 times. So negative 2 times negative 2 times negative 2. And then the power rule, the best thing to do here is go ahead and multiply those and get 21 as your power. Then negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. And then we have our x to the power of 21 with it. And then our last one that we're going to look at here, we have a fraction. And so it's going to work the same way as the multiplication, where both the 2 and the x are going to get that power of 3. And so before, they basically had understood powers of 1. And so I'm essentially doing 1 times 3, so that's why my power became a 3, and 1 times 3, once again, my power became 3. Last thing we want to do is go ahead and apply that power to the base of 2. So 2 times 2 is 4, and then times 2 a third time would give us an 8. And then on bottom, we still just have x to the power of 3. Okay, that's the power rule. Next, we're going to look at what do we do when we have negative exponents.